Hi, my name is Katherine Maloney, and I'm a professor at Point Loma Nazerine University in San Diego, California. Point Loma is a primarily undergraduate institution, and we don't have an LCMS on site, although I do teach LCMS in several of my lecture and lab courses. I'm really excited to show you how I use the new GNPS Dashboard in my courses. The online interface of the dashboard makes it possible to analyze real LCMS data in the web browser without having to install any software. And that's a big one for teaching undergraduates, especially like last year when I was teaching students fully remote. So students can use the dashboard to explore rich LCMS and LCMS-MS data in a variety of different ways. They can easily document and share those explorations with their classmates or with me. And so in this video, I'm just going to show you an activity that I used with students in my introductory general organic and biological chemistry course, commonly referred to as GOB. And in particular in the lab course, I used the dashboard to explore some LC-MS-MS data of natural product antibiotics. So in my GOB chemistry class, students are just learning about representations of chemical structure, molecular formulas, and molecular mass. So prior to having students explore LC-MS data, I first have them determine the molecular formula for the antibiotics tetracycline, chloramphenicol, penicillin G, and rifamycin. Since this particular data set was obtained in negative ion mode, I also have them determine the conjugate base of each antibiotic, in other words, what's going to be the molecular ion, and then have them calculate the exact mass of that conjugate base. So students are then going to come to lab with this information ready. Also, as part of their pre-lab, I have students create a GNPS login. While it's not necessary to be logged into GNPS in order to use the dashboard, it can be really handy. For example, if students want to quickly access other tools like, say, a mass search in GNPS. So I have the students log in, and then once they have, students can navigate to the LCMS browser. The data browser is preloaded with some generic data. I have them replace this path with the path corresponding to the antibiotic mixture that I've run, and you can see it's automatically loaded here. For now, I'm also just going to tick off this show MS2 markers, but I'll return to that a little bit later. From here, students can scroll down. They can see two different representations of their data. This first one is a little bit overwhelming for the beginner, so we'll scroll past it to the total ion chromatogram, or TIC plot here. This TIC acquaints students with the first two dimensions of the data: time along the x-axis and ion counts, total ion counts, along the y-axis. And students can start to get this idea that each of these peaks in the TIC corresponds to a compound in that in their mixture. If I click on a peak, such as this one here at about 2.8 minutes, then students will be able to see the third dimension of their data, which is the mass spectrum, the MS1. Which appears over here. So now students can see the axes have changed a little bit. They've got mass to charge ratio along the x-axis, and then intensity, or ion counts, again for each mass along the y-axis. I can also help students relate this back to the TIC plot by pointing out, if we were to add up the ion counts for every peak in the mass spectrum, they would then get to this total ion counts of 336 million. In any case, what we can see is that this compound that eluted at 2.8 minutes has a molecular ion peak at 321. Students, because they've completed their pre-lab activity, they should be able to recognize that this corresponds to the conjugate base of chloramphenicol. Now, if I click on various peaks in the chromatogram and identify the corresponding antibiotics, students can start to get that there is a mass spectrum for each point in the total ion chromatogram. And then now, once they are sort of armed with this understanding, then they can look back at this earlier representation and begin to appreciate that that it is a three-dimensional representation of all the information contained in the total ion chromatogram. So you've got retention time along here, plus all the information contained in each of those mass spectra. Here's the mass to charge ratio along the y-axis. And then what previously was the y-axis is now coming out towards the students as a heat map on the plot. I can also introduce the concept of the extracted ion chromatogram, or XIC. If I scroll up here to the XIC options, I can paste in, or have students paste in, the masses that they calculated in their pre-lab. So for example, for chloramphenicol, if they type in the mass that they calculated, then they can scroll down and see the extracted ion chromatogram showing a very sharp peak at the 2.8 minutes corresponding to chloramphenicol. If I add additional masses separated by semicolons, then they can see multiple extracted ion chromatograms down here. Finally, students can also explore the tandem mass spectra, or MS2 spectra. So if I come back over here, and now I'm going to click on that Show MS2 Markers. And so within our plot here, now these little blue X's correspond to masses and retention times for which an MS2 tandem mass spectra was obtained. So in the case of chloramphenicol, let's say I don't know that it's chloramphenicol and I want to know what the peak at 2.8 is. I can come to 2.8 and look for that molecular ion at 321 that I saw in the mass spectrum. If I click on that, then I'll get another extracted ion chromatogram corresponding to just the 321. And then down below, I will see actually the MS2 spectrum corresponding to that MS1 ion. I also, if I scroll down a little bit from the MS2 spectrum, I see this button, which will, if I click on it, it will automatically populate the fields to do a masked search in GNPS. So if I give my search a name, sure that it's going to go to me, click submit, then this will automatically initiate a mass search, which is going to search all of the library MS2 spectra in the GNPS libraries and look for a match to my MS2 spectra. And after about 20 minutes, I can, my job is done and I can take a look at the library hits by clicking on View All Library Hits. And when I do that, I can see all of the library entries that matched their MS2 spectra to my MS2 spectra, including several for chloramphenicol. If I want to compare the MS2 spectra for the library entry versus my MS2 spectra, I can click on this View Mirror Match and see how well they line up. They line up quite well. And then if I actually click on the library entry for one of these, I can scroll down and see the structure. And also I can link to other databases such as the Natural Products Atlas, NP Atlas, or MIBIG in this case for chloramphenicol. So that's a very basic introduction to LCMS data exploration that I've done with students in my GOB class. You can find a link to the full activity, including the pre- and post-lab assessments, in the description of this YouTube video. For a more detailed exploration with actual messy data, you should definitely check out Allegra Aron's video tutorial about using the GNPS dashboard in a Tiny Earth course, and that's also going to be linked in the description.